Hello, how are you?
Hello.
How's everyone doing this week? I know Jesse and I met with Samantha this week, um, and I don't know, here he is. And Sadena had a presentation she wanted to do on childless hacker.
Morning, everyone.
Hello. So why don't we? I guess we could give updates if people have anything they want to update us on in the mentoring group, and then maybe we can get to Sadna's presentation on childless hacker. I know that she has that.
Yeah. As a sort of minor comment, I don't know if people get. I don't know if everyone in the lab gets that, but there should be like a direct message from something called Slackbot, and you don't have to reply to that. But if you do, it kind of should be. You can see our responses in the open chat forum channel. But it should come from a DM, and if you respond to the DM, it'll basically just be like a very four basic questions. And you can basically just, in these updates, if you don't have anything to say, you can basically just go through those questions, which are basically, how are you feeling? Um, what did you do, like, since last week or whatever? Or what are you working, and or what are you working on currently? This- it- The Slack bot basically says, what have you done? It'll come out like Friday, and it'll say, what have you done in the previous week, and then what are you working on today? But you can just say, what's been on your plate, or what have you been looking at? And then the final question, which is kind of important, um, even for us like as mentors or other people in the lab to hear, is there anything blocking your progress? Or is there anything that's holding you from going where you want to go, or a question, or need to meet or talk about anything? So, um, you know, um, I'll I'll have more things to say later on, but just as a general, like, if you're ever not sure what to say during this part of the meeting, you can just do like this format, and I'll do a very simple version of myself right now, which is like, how am I feeling, or what's up, how am I doing? Pretty good. It actually was a pretty good week for me overall. I've had uh, a lot of, as you all know, sometimes there's weeks where things move a little bit and things in your life kind of go in a direction, and sometimes there isn't. And this on that scale for me, it was a pretty good week of like, yeah, things are moving, and I feel like personally I've been okay in that process. What have I been up to? I've been up to a lot of things in terms of the lab stuff. I've been up to some conference submission related things and a bunch of other stuff to talk about later. But had some meetings with people this week too. It's good. Anything blocking my progress right now? Um, I need to solidify, especially for the New York Celebration of Women Computing, some times. A lot of people have said some things. I've been in conversations this week, but I kind of need to finalize that, and then I just need to. The only other thing blocking my progress really is I have to put a little bit more structure to some of the things I'm fleshing out or submitting to some conferences. But that's about it. So you don't have to do those formats, but if you want to, or you're not sure what to say during this time period, you can kind of just say, how are you? What have you been working on? And is anything blocking your progress, or do you need specific um, help on anything? Just so we all know that. So I'll turn the mic over to anyone else who wants to give updates for their week. So
Actually, I
great
had
to see you
something.
all. Sorry, what's that?
I had something to say about that. I have to set up those
Yeah.
bots in different channels. So why don't I set those up? I should have set them up in the first place, but I think I can set them up in the intern channels. But if it'll usually message you, and then it'll ask you the questions at a certain time of the week. So I might do that. And
Okay.
yeah,
Yeah, it can be kind of a difficult thing because for I think it just shows up as like a direct message from a bot looking thing. It looks sort of unassuming and maybe unimportant or like almost spammy. But it's kind of a nice little automated process of checking in. So again, not mandatory, but because we don't have like a regular stand-up meeting, we kind of help. But anyway, um, I think we're ready to pass the mic around. So does anybody want to share where they're at this week?
I can go. I don't think I've ever gotten that DM actually, but I've had a pretty good week.
Very possible nobody got it yet.
Oh, okay.
So sorry if not, but yeah, go on, please.
Okay. I've had a good week. I've done some more reading on critical periods in development and AI stuff related to that. I don't remember what the other questions were, but blocking my progress, I guess I would just say like studying for midterms, but other than nothing research related yet. Blocking it.
Okay. That's all good stuff.
Good.
Yeah.
Anyone else?
I think Sadena was going to say something.
I think I can agree with Shaima. It's midterms week, so I feel like that's like the major stressor of like things that are blocking progress. I feel like once midterms are over, I feel like things are gonna calm down a little. Get back into like on the ball for research. But the week's been good. It's been a little stressful and busy, but can't say I haven't made progress. I've just like been doing reading, working on the PowerPoint for this, and just like gathering some of the stuff that I highlighted.
Good.
Okay.
You guys hear me okay?
Yeah.
So I know midterms are kind of killing any progress that I've made since I met with you both this week. Which the meeting was really well. I was able to kind of think of some new questions to focus my topic on. Other than that, the week's been pretty decent, studying stress, and yeah, so just trying to more focus my thoughts in the next couple weeks about where I want to take my research and work on what we spoke about in the meeting. So.
Good. Thank you.
I can go ahead.
Okay.
I was traveling this past week, so I missed the last meeting, and I have quite the reading list to catch up on. But otherwise, no obstacles. I'm excited to get back into it.
Okay.
Great. How was your travels, Amanda? I know that said you were gonna like. I don't know if you're going hiking or doing something. You're doing something kind of fun, I think.
Yeah,
So, you had a good time.
We were in Arizona for a while, and we spent a couple days in the Grand Canyon, and we hiked down in and back up, and it was breathtaking. Yeah, very fun. And it was warm. I live in Michigan, so it's like 20 degrees this morning, but it was like 70 in Arizona.
Okay.
So
That's. I'm envious because I'm in Boston, and let's check. It's just above freezing again. There was like 70-degree days like once or twice a few weeks ago, and then this whole last 2 weeks has just been like, hey, we're gonna maybe get above freezing today. And I'm like, oh, it's gonna be nice. Maybe we're gonna settle that. And it's been really frustrating, honestly. So that's great. I have been to the Grand Canyon once a while ago. It was good. I have a question for you. Maybe it was me. Maybe I'm biased. Does it look different when you're staring at it with your eyes in person versus like a photograph, or obviously other things? But does it? It's a great place, but it just felt so weird to see like what my eyes saw versus like when I was in a picture looking at it.
yeah. When you're actually there, you can feel how big it is, and you don't get that from a picture. My favorite part was because we hiked down into it a bit. We could see like what we had like the distance we had traveled and the height we had traveled, and that was just surreal. After doing it, I was like, I didn't know I was capable of that. I didn't know a human being could do that.
That's cool. Yeah, I felt like my pictures were way better than like. It was just I don't know if it was just like when I took pictures, the pictures looked amazing, and then when I was there, it felt like it looked very. I think it was just the way it was, the air or something that day, but it felt really different. It's a great place, everyone should go, but it was it was weird for me.
We had pretty clear skies and low dust levels, low air pollution when we were there, so that probably made a difference.
Okay, I may have had high dust levels and other things. So. But yeah, congrats for escaping the sort of northern coldness, let's say. All right, cool. Thank you all for the updates, and also thanks to everyone who's people have been very good about reaching out, talking, asking questions, and meeting when you're not sure about stuff. And I think that's been good to see. And again, I personally feel almost privileged. Maybe isn't the right word, but I feel really happy that to have in this group of interns coming through at this time. I'm really enjoying the process on my end, and I'm happy with things a lot. And I don't know if it's maybe because I'm sort of like a younger. I never really had a batch quite like this before to go through this, so I feel like, ooh, like, you know, when you're still new to things and your Bradley's like maybe like, oh yeah, that's how it is, good job. But I just wanted to clarify that. So I know. Oh, were you gonna say something?
No, I wasn't.
Okay. I forgot I'm on camera right now. So I know Sadena has a presentation, and am I saying your name correctly, Sadena?
Yes, you are.
Sadena. Okay, great. Okay.
Penta.
So I know. Just is there anyone else? Is there anything else we need to cover, or do you want to just dive into that now? I think we're ready to dive into your presentation.
Okay.
Okay, great. Let's do that. You can share your screen, yeah.
All right. Let's see if this works. Hopefully.
It can be finicky. I just updated my Chrome, so hopefully it works better for me when I try to do it. Oh, we see it. I see it.
All right. Awesome. So I'm gonna press. Okay. Can you guys still see this?
Yes.
Okay. Beautiful.
Yes.
So I kind of did like more of like the major highlights that I took away, because I feel like if I did like an overall sense and just like took more out of it, we'd be in here all day with me. So I kind of diluted it down enough to like what makes sense to me and like major points that I feel like are cool to share. So key terms. This is obviously like super helpful because knowing these gives you the gist of the whole entire article, because it kind of just like dives right into each of the term and like your understanding of it. So just to highlight like what each one is. I don't know if you want me to like read through each one or just like have it all out, like whichever's.
We can read through them, each one.
Okay.
Yeah.
So childless hacker, I feel like, is a more important one. So this is an algorithmic level of cognitive development extending the ideas of learning and programming by drawing from hacking, such as that the specific medium values techniques and practices of hacking for a rich set of hypotheses about learning, particularly in children. In gist, this is kind of like the whole entire article talks about this, and it's more of like highlighting the like the connection between development in the way humans learn and then how programming and coding and just in general like hacking works. So we're gonna dive more into child as hacker. Hacking pretty much means making coding better along many dimensions through an open-ended set of goals and activities. Learning as programming, which is like a computational level of learning, claiming that human conceptual repertoire can be understood as a mental programming language, and learning as a kind of programming. programming in code a particular expression of a particular computation in some programming language. Programming induction is learning programs to explain how observed data were generated. And then programming language is language with a formal syntax, semantics, express computations, typically in terms of instructions that the programming behavior of some machines are. So a lot of these terms sometimes fly over like your head. At least it did for me before like I really got that. Like I had to read this article twice before I fully understood like what I wanted to take away from it and like what a lot of it meant. So moving on to the next one. These are just like the highlights that I took away from this. So childless hackers both a fertile metaphor and hypothesis about cognitive development. So it's pretty much just saying that like human learning functions through structured and probabilistic and program-like articulation. So it's like human learning is kind of like the computer programming. So computational coding language is written expression for human mental representations of learning. And then like most real-world problems require real-world solutions that are complex enough that it doesn't rely on like a single metric of utility or unified process of development. So this kind of like dives into like why we have hacking and just the understanding of how like using programming works in terms of making it more sophisticated to understand real world situations that are more three-dimensional than like what you would see like on the surface. So it's pretty much like arguing that there needs to be like a diversity in the language in order to create programs that are sophisticated enough to compute the dimensions in real world problems. So it's like variations in one language to tackle different areas. I kind of like thought about the idea, like I remember Dr. Bradley was talking about this, I think it was in the last meeting or the meeting before. It was like the layers in like the meta brain where it's like the different folds kind of like work off of each other to make this more formal, like kind of like big grouped idea of like different levels of and correct me if I'm wrong, like different levels of programming to like kind of like mimic the brain or just like the different functions of the brain.
Yeah, that sounds good. Yeah, I think that's a good insight. But yeah, go on. We can talk about that after the end.
I feel like this like reminded me of that because it's like, again, like when you look at a human brain, it's not just like one specific area working on one specific task. It's generated through like multiple versions or like multiple dimensions of understanding like different folds and layers of like even like the smallest thing, like even counting. So it also argued, like the article also argues that standard learning algorithms need to expand and be more malleable while consisting of different activities and values to be more realistic to the human capacity of learning, mimicking to like towards human learning. And then just like to understand like hacking in general, which was like a really good takeaway for me was like hacking is more about exploring the limits of a complex system and pushing the system beyond what initially seemed possible and make code better. So it's like seeking to improve code to make more accurate, faster, clearer, memory efficient, and like effective systems in a real world care more about managing complexity and understandability. So this kind of like it made me think of the idea of jailbreaking your iPhone. So I don't know if you guys can relate to this or not, but like back when I first got my iPod Touch, like when they first came out, I think this was like 2012 or 2013. I remember just like the iPod Touch was very limited in like what it could do. So a lot of my friends used to sort of like hack the system. There was a program that you could pretty much download onto your iPod, and it structured the programs in it, and you could do like the craziest things with your iPod. So you could change like colors of like different apps and do a lot of the stuff that you can do with your iPhone now, but like with the generation that you had then. So it's like hacking the system almost, but like making it more modular, accurate, and just like pushing their system beyond like what it like initially could do. So like that's like kind of like what it reminded me of. So code operates on multiple levels, with each level embodying one language inside another, so that it can define data structures and be manipulated and analyzed. All programming languages are programs in which any knowledge that can be expressed in any program can be integrated into a single formal knowledge representation. So again, I kind of made this little structure on the side right here where it's like the multiple layers that go into making a sophisticated program and just like understanding where like a lot of the data's come from. So when you like look at code, like you have to put multiple codes together to create like one thing. So like a few words equals a sentence, like a sentence equals a paragraph equals a book, and like a book equals a library. So that's kind of like the metaphor that I had in my brain for like how coding works and like how making like different programming structures like work, and just like what the process is in terms of creating like knowledge that can be computational and represent like different structures or databases. Program induction, I feel like this was also something really important to highlight in general because program induction is discovering programs that explain how observed data were generated. So it's like the theory draws on inductive programming literature, which dates back to the birth of cognitive science and just like how different programs came to be. So it explores like different subclasses of programs and other possible implementations of theories. And this also applies to like more broad developmental phenomena, which is like counting and concept learning and kinship in like programming structures. So it builds on formal study mechanisms that comprehend the world by inferring computational processes that could have yield observed data. So it's pretty much just saying that like it looks at a timeline of different structures to see like how it was generated and understand where those connections come from in order to make a new one. So it's almost like when you have to like go back into like your history to find the origin of something. This also just reminds me of like when you're doing literature review and you're trying to find the origin of like a specific idea in there. It's like you almost like end up in a black hole of just like figuring out where the origin comes from until you figure it out. And sometimes you don't, but sometimes you do. I feel like when it comes to program induction, it's more specific in just figuring out like where the origins of that specific program come from. And then last part, like hacking and children have a unique sameness in which both are motivated by their own curiosity and end up learning and improving skills. So one of my biggest takeaways was this one line that I talked about on page 907, which said, "Indeed, as children age, they rely decreasingly on strategies requiring external cues and increasingly more on memorization, a transition humans formerly teach and discover independently." So again, like relating this to like childless hacker and just like the connections that it's making to hacking. So it's like emphasizing on this like transition of making code better or like making different programs better to mimic this transition of simple learning or like simple ways of like understanding certain things to more complex or more clever and easier ways of doing that, which is like memorization. And it does talk about how like coding can be mimicked into this, and just like how hackers kind of think in the same way as children, in which like they want to improve certain things like within their code or like within their learning development. So another metaphor that it also talked about like briefly towards the end was childless scientists. And like this talks about how children structure their foundational knowledge in terms of like intuitive theories, analogous and important ways to scientific theories, and build knowledge through epistemic values similarly to the scientific process. So what it's trying to say is childless hacker and childless scientist have like this overlapping and complementary notions of knowledge representations, epistemic values and practices, and constraints on learning that complete cognitive development ideas. So it's kind of like putting the other half of the circle into like the bigger figure. And like my largest like takeaway from this was just like the idea of both machine learning and psychology would benefit from a unified effort to pursue the roadmap of developing a computational account on human learning. So the reason why I highlighted this specifically was because while reading this, it was a little difficult for me to just like fully understand where like cognitive science, like developmental, like psychology come into play. But the article did a really great job just helping you understand where the psychology aspect or where like the human component of coding falls into place, because I feel like sometimes when we look at coding, when we look at computers, we kind of like dehumanize a lot of it in a way where we can't really draw specific connections, and I feel like that holds back a lot of the developments that we can make. Whereas once I read this, it helped me make those connections and understand where when you understand development in a human, you can also mimic that in AI or in coding to kind of like structure like the way the learning process or like the learning algorithms go, to make it more sophisticated and kind of like generate a more updated version of whatever like knowledge or program that you're working on. So definitely like a really great read for me, because a lot of it was just kind of like more like an understanding of what I need to know to get started in the lab, but also an understanding of what coding is, and kind of like it's almost like dumbing it down for me, if that makes sense, where it's like I didn't really understand like the different components that go into it until reading this, and it just really helps make those connections between cognitive science and like psychology and just how that relates to like AI learning, deep learning, and just like the different ideas that we talk about in the lab. I feel like I made a lot of connections to like different topics and subtopics that both Jesse and Bradley brought up. But yeah, definitely recommend this.
Yeah, I think that's great.
Great.
Yeah.
Yeah. Thank you. That's a great length. That's a great like. I think it's a really great kind of presentation for this stage of a lot of things, and I think that was, I think the execution of that was really well done. So yeah, there's a lot of things to talk about with that. I don't know if you want to start, Bradley, or do you want me to start with some things?
Why don't you start with some things?
I think we talked about this a little bit in a lab a long time ago. So it's good for me to hear someone else approaching it, because I kind of have memories about different things. What I would start with for people who are new to the discussion and don't know like a lot about Joshua Tenenbaum and kind of what the some of the context. First of all, I will say, the Childless Hacker paper, as far as I'm concerned, is on the scale of easy to read and interpret and really almost nice flowing papers to not. I don't think it's really that accessible of a paper. So I want to say it's a good paper with a really interesting concept, but I don't think it's necessarily like the greatest of papers. And I want to say like it's a little bit dense or like inaccessible in some ways. It's not really. It's not like there's a lot of context that I think is really important that isn't in the paper. So if you're reading it for the first time, I think it can be challenging, and I think this is a very good take on that. And so what I would try to add for people trying to understand it is really trying to situate it in the context of like there was some mentions of like the history of cognitive science, and there's sort of a complicated history between cognitive science and artificial intelligence and computing and machine learning and symbolic learning or processing, and these terms and what do they really mean, and it's so hard to really communicate that. But I think it's important to see Childless Hacker as sort of an attempt, and I would almost say, not correct me if I'm wrong, but feel free to like add on this, Bradley. It's kind of an attempt to further justify the bridge between human development and learning at younger stages in life and how that changes versus like kinds of intelligence or interpretations in computing that maybe don't have as developmental a lens. And I mentioned this last time a while ago, And maybe I can share my screen. Okay.
Yeah.
I can share. I think you can see my screen.
Yeah.
I'll mention this quote, and this is a little bit dense quote, but I'm going to kind of walk through it to kind of make my point. Very old quote from like the 50s, the 40s from Norbert Wiener. It was a very, very long time ago thing. Cybernetics guy. But basically, he's saying that an important difference between the way in which we use the brain and the machine, as in like AI or any kind of mechanical understanding, basically, is that the machine is intended for many successive runs, either with no reference to each other, or with minimal limited reference, and that it can be cleared between such runs, while the brain, or in the case of like personal human knowledge and development, in the course of its nature, never really comes close to that. It never clears out its records. It's a very different kind of function. So the brain, this is commentary on the brains are computers narrative. And so he's saying, the brain under normal circumstances is not the complete analog of the computing machine, but rather an analog of a single run on such a machine. So he's saying basically that when, like, we all have computers now, so it's probably a much easier analogy for us to understand than like the 50s and the 40s, like almost 100 years ago. Whereas, like, if you turn off your computer, or if you restart your phone or whatever, you've just created a whole other recycling of the machine. And now there actually is more memory and more things that it can transfer over to, in a sense. So it's maybe a little bit more like what we're talking about. But it's really important to consider how what's kind of being said, and what Josh is getting at, I think, and I'm trying to also find one of his there's a really good, in some of his other like presentations, Josh basically maps out the sort of developmental stage in human development. There's like, birth or pre-birth stages, 1 to 2 infants, 3 4 toddlers, young people, teenagers, adult, and then older age. And how when we talk about intelligence, and artificial intelligence otherwise, there's maybe a tendency to speak about intelligence in machines as if it's sort of like a monolithic thing in machines, whereas in humans, very obviously in humans and other things that are alive, there's an arc and a development and a trajectory. And so I'm kind of maybe inarticulately trying to create some background here, but I think the Childless Hacker paper is sort of attempting to build upon and like there's maybe a little more accessible concept of, children are scientists or very natural scientists. And you hear like Neil deGrasse Tyson or Carl Sagan, these other figures in like science communication say, children are not always experimenting all the time. They want to learn, how do I do this, what if I stand this way, what if I mismatch this thing. And then as they kind of develop, maybe they society beats it out of them. So, stop, play by the rules, stand up straight, and don't stop fussing around as much. And sort of commentary about that. And I think Childless Hacker is kind of saying, in a cognitive sense, what's going on there. So like, is it a related term is like play and learning, and how do they mix? So I think it's just I'm kind of losing my train of thought. So do you want to jump in and say anything, Bradley?
Yeah, I have a couple things to say about. First of all, Sadena, great presentation. I think you made some really nice insights, and you laid it out really well. These are some of the themes we've been talking about in the group, and I know Jesse is a real fan of this paper, so I'm glad that we had a couple.
I just tried to pull up your presentation, Sadena. Could you maybe share your screen again so we could, or unless Bradley was going to, just so we could like point at different.
Well, yeah. Why don't you pull it up, Sadena?
Sure.
I can't open the link that you sent me.
Oh, my bad. I think it's like I like updated the
There's like
presentation again. I'll send it to you afterwards again too. Just so.
Yeah. Okay, so this
But
is
you're gonna say
yeah. Well, I guess yeah, I guess the key terms are a good place to start. So yeah, this is a nice like I guess they're trying to build an analogy between hacking, which is kind of one of these terms that we've made up with the I don't know if it's pre-computing, but I guess it's definitely people think about it in terms of computing, and they have like this. There's this mythology around it, but I guess that's a pretty good definition of hacking. Making code better, and then this open-ended set of goals and activities, which is of course means that there's no goal in what you're trying to do. So, one of the things in early computer science is when they were doing a lot of the early AI, they'd play these strategic games like chess or something like that, and there's sort of a strategic endpoint to that. And so, you have this set of strategies that you're trying to play, and the idea would be, okay, we can play chess with a machine. We can use a symbolic system to do that. But then there's also this open-ended aspect where you have to learn new things. And so this is it's still a big problem in AI that, we can't necessarily get the machine to learn new things. If you, say, for example, a standard machine learning algorithm, you train it on data. You train it on data, and that's what it knows. It might be able to generalize to something else similar, but that's not a guarantee, and it's not very good at it because I think people have seen examples of this. You don't have to go too far to see that. So that's a big problem, and I know that Ankit Grover is really kind of interested in this problem of generalization with programs. So how do you generalize? If I train my algorithm on one data set, how do I generalize to something else that I've not seen before? And in development, babies and small children can do that. Maybe they don't do it very well, but they eventually get good at it, and so that's one of the hallmarks. So Jesse, what were you going to say?
Yeah. One just to kind of pair off of this, there are two things I wanted to say. One, and this actually is something I is maybe this may be a personal thing, but when I heard the term when I first started hearing the term hacking along like a while ago before I knew anything about AI or whatever or anything about computer science or whatever, I actually when I heard hacker, I thought basically someone maliciously trying to break computer programs or hurt people. That was where I was coming from when I first heard hacker. Um, and what actually changed my mind about it, yeah, what actually changed my mind about it was ironically, I, I, I had no intention of doing anything with AI seriously at the time, but my cousin was a smart kid and he did a bunch of, he was visiting colleges and he actually, he looked at stuff here in Boston and a bunch of things. And we went to MIT and they used the term hacking in a very different way than I ever heard. And they would talk about hacking in a way that was a lot like kind of what Sadhana got at and this paper is talking about, which is like improving. And I think Sadhana's analogy of basically like jailbreaking or modifying your I think it was iPod Touch or something like that, an
Yeah.
iPod. I think that's very apt. And also like I will confess some of my nerdness. Like I have like modded. I've like have played a few video games on my personal computer, and I've really enjoyed modding them or using these hacks or these developments in the code that people have made to enhance the game or make it do totally different things than it was originally intended. Like you could have your character developed your way or get like unlimited gold or whatever you want to do. And I think just to kind of reiterate, yeah, that was a very good analogy. And for people who aren't familiar with the term hacking, outside of the context of like, what Russia may or may not be trying to do to everybody who's opposing their 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 involvement with Ukraine right now, like this nefarious sense of bad guys trying to screw with your computers, hacking in the context of how does one modify an existing structure or even a given thing they're familiar with and play with it and do something with it beyond its original intent. And so to go back to kind of what Bradley was saying about this major issue in any kind of learning, and like maybe a nice way to talk about this also is like machine learning or human learning or natural intelligence versus natural versus artificial intelligence. Is how does generalization happen? How does world building happen? How does transferable skills and knowledge happen? And I think this is all really, the paper and childless hacking and a lot of the things that Sadena is pointing out are really interesting in the concept of how do we this paper is kind of couched from a very trying to bring, I feel like it's kind of trying to bridge things towards computation and say, well, how do we think about this process of developing code and ideas in a way similar or analogous to what kids are doing or all people are doing. So that's kind of my hacking story arc narrative tangent. But I thought it was really important. I think those were really interesting things to point out, and interesting concept to think about. So back to you, Bradley.
Okay. Yeah, so then the other thing, too, is that we talk about open-ended, and there's this whole area of innovation that maybe isn't as familiar to people who work in some areas of, in an academic sense, in like AI or even in psychology, but in artificial life, they've been working on this idea, and even in evolutionary biology for a long time. And the idea, especially in evolutionary biology, there's another analogy between what evolution is doing and what maybe like we're doing by learning things in this process, not necessarily just giving the computer a training data set and letting it encode that, but actually having this process of learning things, processes, but also like building mental models. And so this idea of innovation is very important. There are a couple papers and books that people published on this. I know we've talked about it. I can't remember. I can't put my finger on the citations, but we've talked about it in the Slack a bit. But anyways, that's a big topic. And when we talk about innovation, we're talking about this open-ended process where there are no goals. It's just like, there are things in the environment, there are things in the sort of learning space, and your agent will maybe move towards those things, and there will be things like rewards or things like more likely paths than others given what you've done in the past. And then those things the objectives keep changing, so where you end up is a product of sort of your current objective, what you want to do now instead of maybe what you set out to do 50 steps ago. The local conditions, what does it make sense to learn, what is the most relevant thing you want to learn. And this is this process of open-endedness. So this idea of innovation where you're constantly trying to figure out ways to do things, like jailbreak your iPhone. You have an iPhone, you could use it the normal way, but that's maybe not what people want to do. Maybe they want to customize it because they say, well, I really like this this feature, but it's not in the phone. So we'll open it up. This is the premise behind open source software development, by the way. The idea being that we open up the software, we can let people add their own features, and then whatever they come up with, whatever their local needs are, then that's what comes into the software, and there standards for putting it in, incorporating it into the software. But you don't know as a developer, if you draw an architecture of the program, what people will necessarily want or need. And so this is the benefit of this sort of innovation and open-endedness, where you just let people, do something, figure out what they need as a feature, let them build it, put it in. And, that's something that I think is a powerful, I think we don't think about it enough in learning, because, we kind of think of this top-down view of things. Like, this is the way it works. We draw out all these pathways and everything. But really, that's actually not, in evolution, of course, it was not the way it worked. And in learning, it's also not the way it works, because you're learning things as you go. You're encountering things in the environment. So that was an interesting connection. And then the other comment I had was about, and Sadena brought this up earlier, was about the layering, I presented on the layering work on the metabrains, I think 2 weeks ago. And I'm going to present more on that later, by the way. But, that is an interesting sort of observation that, there are these different components in an agent or in a brain that play off one another. So yeah, this is nice. This is where you're assembling information into larger and larger units. And this is, again, this is something that we have in linguistics. This is a hierarchical model where you're building things from like the single unit up to like these emergent structures. So, words build sentences, build paragraphs. It can get really interesting, though. I mean, you can have things that are built sort of semi-hierarchically. In other words, you can have an interplay between these levels of thing. And so that can actually create a nice opportunity for innovation. So I'm trying to think of a good example here with this. But, we might have, like, say, for example, a bag of words at the top, and then a sentence structure, right? So you have your words and any possible word that you have in your bag. And then you have a sentence structure, which is the next layer, which means that there are rules to assembling those words. Then you have paragraphs, which is just like the paragraph has to make sense. So there's certain rules to constructing a paragraph. And then book and library are more like, containers. So the paragraphs go into a book. The book, of course, has a topic. Then the library has organized by topics. So, you have this flow. But up in the word, sentence, and paragraph area of this diagram is where it really gets interesting, because you could have, say, for example, a bag of words, and then they get plugged into a sentence. Now, you always have new words that are coming up. So new words are being generated into this bag. And so now, you build a sentence with the bag of words at, say, time point 0, and you build those sentences. And then you come back to that bag at time point 20. And at time point 20, there are new words in there. People have created the words. They're naming new things. They're maybe making up, like portmanteaus, which are combinations of words put stuck together. And so you have a bunch of new words to put into sentences. Now, sometimes those words fit into the sentence structure, and sometimes they don't. So that means that now you have to go and you have to build new sentence structures. And then you have a new set of sentence structures. But then you go back to the bag of words and you find that you have more words that aren't really fitting into that structure. So you go back and you innovate on the sentence structure more. And so you can see this iterative process where you're getting new things that don't fit into the model. And this is the kind of thing we're interested in, because the typical approach to AI has really been like, we're going to assume that this is the way the world works. It always works like this. It's static. And then we're going to build up this intelligence. The problem, of course, is it can't generalize to new domains. If it hasn't seen something, then it's not going to be able to know how to deal with it. If you train a AI, say, on like what traffic lights look like, how's it going to know what a train looks like? I mean, let's just assume that the training class is very narrow there. But the point is that you have to really train it very broadly. And even when you do that, you can miss things. So again, back to the bag of words and the sentence structure and the paragraph, those things are constantly innovating, and you're building up this, it doesn't end. There's always this open-ended nature to it, where eventually you'll evolve new languages, and you'll evolve new ways to build words or new alphabets. So, this is, I think, a nice example of this interplay between how things are built up in intelligence. Is for metabrains, the metabrains are more about representational layers, but the representational layers kind of work like that too. There is this, as your representations are built up, if you encounter new things, you have to change your representation to incorporate those things. Otherwise, you don't even have the bag of words to describe it. It's just kind of like, what is that thing in the environment? There's been research on color, on color perception, like cultural variation in color perception. And in that literature, they found that people, when they present colors to people, they have a color map, which is like a map of different colors generated by mixing colors, either additive or subtractive. They mix like the primary colors, and you can generate colors that are objective. So if you have a certain color value, that's the color, right? But then they show people these colors, and they say, what do you name that color? All right. So now this is interesting because you go between cultures, you see that people are naming them different things. Sometimes people don't distinguish between hues of blue, hues of red, whatever. Sometimes they make very fine distinctions between them. And so that's an interesting thing. You go across cultures, it's not even development here, but you go across these bag of words in different places, and they have different words for things, and they're tying it to concepts. And so, but the concepts are constantly shifting because, well, we don't really know why. I mean, they might be more important to people, or they might be less important, but that exists. And so I think that's a really nice, that really ties into this sort of idea of hacker, because that's essential, I think, to intelligence is really, and learning, is this idea of hacking sort of meaning, or hacking concepts, hacking things. You get these raw materials like words and sentence structures, and you have to put together things, and it's always changing in time.
Definitely.
Yeah. So, I mean, that was my rant. It wasn't a rant, but I wanted to go into this pretty broadly and give you some of my thoughts on it. So thank you, Sadena, for that.
I would ask the follow-up question. Do you have anything you want to say after presenting and thinking about it? Or what do you... I guess my question for Sadena, in the most broader functional sense too, is where do you want to go? And this is not a... You don't have to have any refined answer. This is just honestly a straight up question. After reading this paper and spending time in this area, and again, this is a fairly dense paper, so I think you handled it very well. But after you spent time fussing with this thing, which I don't know, when I first read the paper, I'm like, this is great, but what do I do now? I guess where do you see yourself wanting to focus on? Where do you see yourself wanting to go next after looking at this? Do you see, all right, that's kind of enough of this particular layer of the analogy that you've been looking at, or are you interested in some other things? And again, you don't have to have an answer, but I'm just curious if you have any particular ideas or feelings about what interests you or what isn't appealing after all this, looking at this big mess of a paper and stuff.
Well, if I'm gonna be you're definitely right. The paper was dense in a lot of ways, where it throws different types of information at you, where I feel like you could look at different aspects of just psychology and developmental science and cognitive science and still not know enough to really fully unpack the paper. But just in general, reading the paper and my thoughts about it afterwards, I don't fully have an answer for you in terms of where I want to go, but definitely my largest takeaway is looking deeper into some of the analogies that the paper has made in terms of learning, and then I thought about theory of mind and cognitive science in general and how that relates to development in human learning, and then just trying to figure out a way to relate that to even things that I've learned in the paper and new ideas that come up while I was learning. But in general, I'm still, you said, it's kind of a difficult question to answer because after reading it, I was in the same, I'm in the same boat as you were once, where it's just where do I go from here? I have all this information and I have this, what's the next move?
Yeah, and it's sort of you can have, it's now you have all these references and these ideas, and you have a lot of partial peripheral understanding, and it's just, if anything, we can talk about this very openly in Slack, but just for any, like, I kind of say this for like anybody who's going through this process too. Like, after you read something like this, and I really want to emphasize this is not really an easy read or a paper that generously gives a lot of context about like the state of affairs that it's commenting on, I think, or at least that. So like it's sort of a very much a sense of like after you go through things like this, it's sort of like, all right, this is a really deep dive in a really specific concept in a really particular opinion. Like this paper is an opinion about a way to look at a very big problem. So it's very like concentrated on a point and a view, but addressing very large concepts. So it's important and useful to kind of balance it out with maybe broader views of other things too. So there's not really a recommendation or say go look at this, but more like for people that are looking at. I've had conversations with many interns this week along these lines of like what it's hard when you're starting out even just to get a sense of like what is the layer of focus in this paper and how do you get the context to understand it? And that's kind of behind the whole frontier map concept and everything else too. Also, one other thing that came to mind, and I don't know, I feel bad for like tagging someone without really prompting them, but like I know Amanda mentioned some things about analogies recently, and I don't know if I put something in our Slack discussion about that, but there may be some stuff to talk about in the group. If we want to have a session that focuses on like analogies in this way, there's a lot of side discussion about analogies between this and that, or computing machine, or whatever, or in general. So just mention that too. Did you want to say something, Amanda, or you good?
Yeah, I'll just say I'm interested in like what makes an analogy a useful one. How can we use them as like tools to understand things, just like that general question. So I haven't read this Child as Hacker paper, but that seems like a main like
Yeah.
like it's what can we learn from this analogy? But also like another question is like what could the analogy be masking or hiding?
Yeah, and there's a major and very important almost divide or question, a major question in artificial intelligence and kind of cognitive science, but especially artificial intelligence. And when I mean artificial intelligence here, I mean like the biggest, broadest sense of it. A lot of times people say AI and specifically mean machine learning, which is a very specific subset of artificial intelligence, in my view anyway. But a big question is like, how apt are human-related analogies, and how much should we be bound by human-related analogies? Is there intelligence in ways of doing things outside of human contexts that are better for computing certain things or more intelligent in certain ways? Like, obviously, there are certain calculations that work really well that I can't do, but my GPS does really quick. Like stuff like that. So, yeah, great. Okay. This is a segue point into a lot of other things. I wrote in the chat for me to mention something about Gary Marcus. I looked at a podcast with Gary Marcus that kind of ties into a bunch of other things in a cognitive science perspective. It's called Machine Learning Street Talk. It was more actually about like philosophy and concepts and ideas, which is pretty cool in this case. So I might mention that later. I don't know what the best segue for you, Bradley, is, because I know you want to talk about like Markdown and some other stuff today.
Yeah. Well, I mean, we can just make a transition now, I guess. So this is nice. This is one set of discussions we can have on like topics, and this is great. Another thing I wanted to do is give you a little bit more background on how to work on these sorts of things that we do in the group. So we have this. We have these tools for working the way we work, because this is not a conventional sort of approach to working. I mentioned before, and I know this came up in a meeting this week. How do we create these research artifacts? So you're doing research, you're building these references, you're reading. Now, how do we make things that can be then transferable to someone else's knowledge? So people have to, you can do all the research in the world, but if you keep it in your head, it's not worth anything. It eventually might be, but you have to get it out into the world. And so, typically people have used like papers, which are, I think, an endpoint vehicle, not necessarily the beginning. So we want to build these intermediate artifacts. And so, okay. So I'm going to share my screen.
I kind of see the creation of artifacts is sort of like, and this kind of came up a little bit in a meeting earlier, but as a researcher or someone learning, you're kind of interpreting and bringing a lot of things in. Like, we all just did a bunch of work right now, but how do we communicate the context that we just created to other people? How do we get it outside of our mind and contribute to the big, broad narrative of discussions about this topic? And so creating the artifacts it's an endpoint, and it's sort of, it's tough because it's a necessary concretization that other people can understand that's out of your head. But it's also like, how do you fit that with a broader conversation of what's also happening? And that's really an art form. So I think what Bradley's talking about next is like some of the nitty gritty of like, how do we do that? Right?
Yeah. So first of all, I did want to talk a little bit about research and how to find things in the literature. So this is my Google Scholar page. Google Scholar is a nice tool for looking up articles. You look up things on Google, you find, like, you use a search term and you can find different articles. But you can also look into specific articles. So why don't we take this article here? This is a paper from the Open Worm. This is kind of like a summary of the Open Worm Foundation's work. This was published in 2018. And you'll notice that if you look something up on Google Scholar, or sometimes you just do the Google search, it offers you this information here. Total citations cited by 84. If I click on this link, I end up with this list of references. So we were talking before about like going from the paper and finding things that are related. This is a tool that allows you to do what they call forward citation. So this is a paper that has a lot of citations in it, and those are the backward citations, the ones at the end, the ones you cite in the paper. And you can follow those back to like the origins of something. And, it's just a matter of like going through that list of citations. I don't know if I can look at the paper here. But, you have these citations at the, I don't know if it's showing the citations, but these citations, like number 60, and they show up in this side here. So, this has like, I don't know how many citations in this paper, 63. So you can look up any of these. Some of these papers are just like for reference points. Others are like history. There's a history behind it. So this CompuCell paper comes from 2004, or the cybernetic embryo paper comes from 2017. The one from 2004 might be the basis for some earlier concept. So you can follow things through the literature backwards like that, where you go back to some paper of origin, and then you go back further to other papers of origin. And I think Sadena mentioned in her presentation that she was trying to find the origin of some of these concepts, and it's very hard. And indeed, it is very hard to a lot of times to get a handle on where a concept comes from. Sometimes people propose it in a paper, and it's like a landmark paper, like the paper by Claude Shannon for information theory. But sometimes they're very subtle. Like sometimes people just start publishing on something and just kind of appears in the literature. So the one way you can find things is to go back to the reference list, find a reference, and then keep walking back, like this paper here. You might go back to this paper, look at its reference list, and find some origin point for some concept, and just keep following it back through papers. So that gives you, then that gives you also a map of like going from paper to paper and seeing how that concept evolves. But what I wanted to also talk about is this forward citation. So that's backward citation. Forward citation is where I take this paper, which we were just looking at, and I click on this total citations cited by 84. Now it gives me 84 papers. These are all papers that cite the paper I just showed you, this open worm paper, in their bibliography. And so this paper from 2020, Thinking Through Other Minds, A Variational Approach to Cognition and Culture, they cite the open worm paper in it. And so this is the paper. And this is a nice example because I know this paper, I think we reviewed it in one of the lab meetings. And so, yeah, and this paper has its own bibliography, and it's going to link you to other concepts. So going forwards from that open worm paper, we go to this Thinking Through Other Minds paper. And of course, that paper is very different from the open worm paper in a lot of ways. It probably talks about, theory of mind. It talks about cognition, culture, probably some free energy principle stuff. So then you can say, I want to walk from the open worm paper up to this paper and then down to maybe the free energy principle, which is something that, you can trace back to its origin. And so I know for a fact that the free energy principle has a very definitive origin. There are a couple of papers that are really key in that literature that started it off. And it was Carl Friston who first proposed it. And so he's on this paper as well. But you go back, I think it was like back in the aughts, like the 2000 to 2010 period when this was being published, first being published. And then since then, they've published a number of papers in different areas that are related to this using this principle. So you can move around the literature like that. You can move from like a method to a concept to what it's leading to in the literature. There are a lot of ways you can navigate the literature other than just simply Googling or putting search terms in a search engine and finding, a list of things and then just saying, okay, I'll walk through these one by one and see where I go. That we might call that the brute force method. But this is a more focused method, or maybe it's a more serendipitous method of finding things in the literature. And, you're kind of focusing on certain concepts you read about, following up on those, but you're doing it in a very, controlled way. But then you're also using these kind of tools where you're looking at what's been cited in the paper, where that paper has been cited, and you can really move through the literature in that way. So that's one thing I wanted to talk about. Any questions on that or comments?
I have a comment that will lead to some other things later, which is that in terms of finding the origin of certain terms and whatnot, always feel free to ask questions about that, because as I said in one of my intern meetings this week, the area we're looking at in so much of what we're doing is extremely interdisciplinary, and it's just straight up challenging at times. Like the free energy principle is a pretty clearly defined thing with it. Carl Friston kind of has the modern day ideal of kind of being like, when you think Carl Friston, you think active inference and free energy principle. Well, that's great for like publishing and all that like great stuff. But a lot of really important concepts and ideas maybe either don't have that clarity of, oh yeah, someone wrote this paper where it says exactly what this is directly, or maybe even more so. And I'll really briefly allude to this, and maybe we'll talk about it later at another meeting. Maybe an even more common thing is different fields of studies simply have very different ways of talking about similar concepts. And Richard Sutton, who we kind of mentioned previously as a major player in like reinforcement learning and a lot of like he's one of the old veterans of the field of a lot of computer science related stuff, and he just released a preprint about how do we deal with definitions across psychology, AI, economics, control theory, and neuroscience, and how do we reconcile all those different definitions? And this is not an answer. This is a paper of him just genuinely looking at those topics. There's only like a 4-page long paper, and he's just kind of going through, he's going through this he's presenting this challenge of like, how do we try to move towards a common model of a decision maker? How do we talk about that? And that's just to point out, like, this is something that someone who has more experience than pretty much anybody else in the world currently in this area is making a simple archive preprint paper right now. Maybe they publish somewhere, but this is a very simple. I have a direct link to it here. Like, this is not front page Nature high level thing. This is a very short paper with some very simple models, and it's going through some terms like perception and additive rewards and ground rules and like this is someone fleshing out an idea and talking about this big long quest for progress in this area, and it's kind of based off of a conference that I may try to attend. I just found out about reinforcement learning, decision making, multidisciplinary conference on it, or NeurIPS. And just really quickly, just mention this really quick. Like, this is where the challenges remain. Like, this isn't just something that is figured out and you just have to read the right paper. Like, no, this is like part of the hard work about interdisciplinary research, and especially cutting edge frontier related stuff is, it's almost like having to learn multiple languages just so you can translate between them in order to quote unquote hack. I'll go on camera. You're hacking a whole new meaning or way of using. You have these established fields of study. It's like, okay, well, how do we push this forward? It's hard. So yeah.
Thank you,
Sadena. Great to hear from you today. It went well. So yeah, I'll turn it back over to Bradly.
Yeah, so Amanda put in the chat something on for philosophy and philosophy adjacent material. There's philpapers.org. So there are different tools that you can use, field specific. Some are more general, and then your library has like a number of different tools, search engines that they use, and there are different ways that they associate papers. So what I showed you is forward and backwards, search. A pretty informal method, but there are other ways, other strategies for finding things in the literature, and of course, I'm not a library scientist, so I mean there are other people. They may have like more developed things in their field that they use, more sophisticated tools, concepts, things like that. Like, that's a whole field, just to let you know. So thank you for that. I think that was a nice set of connections to what we were talking about. Now I wanted to talk about Markdown, and what is Markdown, and why you might want to use it in your work. So we do a lot of stuff with open source, and in open source there's this language that's been developed for formatting text, and so it's not something that it's kind of like HTML, but it's a little bit more versatile. I don't know if you've used Discourse, which is a forum for discussing things, but they use Markdown in their like, if I know that Shyam has used NeuroStars recently. NeuroStars is based on the Discourse platform, and they use Markdown in the chat. So when you have a chat message, you can use Markdown to build your message, and it formats everything, and it looks nice. It's better than, actually, it's a lot better in HTML because it's easier to work with. You can incorporate components of HTML in Markdown, and it reads. And the best thing is you can you can push things to GitHub in Markdown, and it looks formatted, and you can generate documents in that way. You can write books. So this is my tutorial on Markdown. Markdown is a language there are variations of it. There's one we're going to talk about the version for GitHub. And then this is a short hello world example of Markdown. So you can generate hyperlinks, you can put images in documents, you can have headers, irregular text, and so forth. So this is something that was developed by John Gruber and Aaron Schwartz. So Aaron Schwartz, of course, is famous for open access activism, and John Gruber is a tech person, and they worked on this, developing this language, what they call markup language, which is Markdown but plus HTML and XML. So those are languages you may have heard of, and that's kind of the principle behind those languages. Is it's sort of like it puts metadata or meta markers in the text to format it. So so Markdown comes in different flavors. There's this I'm going to go to the slideshow here. There's this general Markdown, but then there's also there's a version for R, which is a statistical package. If you want to write documentation for your statistical analysis, you can use Markdown for R. You also can use Markdown on GitHub, which is, of course, how you publish things on GitHub with Markdown. There are different versions, there are different syntax differences between those versions, but they basically allow you to do, work in that platform and generate, have as much freedom as you need to generate nice documents. The GitHub flavored one is tied to version control, so we'll talk about that in a little bit. And then you can also do things with these Markdown documents. So you're like, well, this is kind of trivial. Why do I care? So, you can go and take a document, make it in Markdown, and it looks nice and formatted. But then I have a nice formatted document. Looks like a web document. So what? But I can also go further, and I can take that Markdown document and create different versions of it. So, for example, Markdown, it allows you to integrate with LaTeX. So LaTeX, of course, is a mathematical formatting tool or a language. It allows you to write nice equations, nice formatted equations with all the symbols. And LaTeX itself is very opaque as a language. If you write a whole document in LaTeX, and I know Jesse's a fan of Overleaf, which is a way to generate LaTeX documents, but you can do this in Markdown just as easily. Although there's some other formatting, it won't allow you to format things in, according to style guides and things like that. But that's something that I think actually if you could do, overcome. So, and then you can also you can convert Markdown to HTML or any other language you want. So this allows you to create attractive technical documents. This is something that we have. This is something that we did in the DevaWorm group a while back. This is an educational application. So we're building these tutorials called the OWDW Education Project. And it's something I worked on for when I was a Mozilla Open scholar. I did this work, and I generated these documents for OpenWorm and DevaWorm. So basically what this is it's a series of educational materials for these different topics. So this is a description of a Turing model in developmental biology. This has the header, it has equations in it, it has images that show examples, and you can format it kind of like a paper, but it's it's an educational document, and you can really do a lot of nice formatting. So these equations are generated in LaTeX. You can put LaTeX code in, You can put in, you can align the figures. You know, everything is, you can build things like that. And then it's all, you know, this is hosted in GitHub. So this is all something that's pushed to a GitHub repository, and you can have people issue pull requests against it and things like that. So really you're using minimal syntax here, and you're building it like a wiki. So this is something we talked about, generating wiki stubs. So this is something that, you know, if there's a topic you want to explore, we might do something like this, where we have a curriculum where, you know, we have these different topics and we link them together and we generate these kind of documents. Now there's a difference between Markdown and HTML. So which ones, I show you two examples of like three things here. Header 1, header 3, and then this table. So which ones were written in Markdown and which ones are built in HTML? And just looking at this, you can't really tell the difference. But, and then of course this table is even more complex than the headers. Which one, is this written in Markdown or HTML? So the answer is that, okay, so number 1 here for header 1, the top one for header 3, those are the ones that are made in Markdown. The ones below are made in HTML, and these are the syntax differences. So there's, you know, it isn't a big deal there in terms of syntax. But the tables are actually kind of interesting, because in HTML, there's a lot of code for tables. You need to define a lot of parameters. In Markdown, it's like you draw a table with characters, and it's, you know, it's a lot more intuitive in terms of building the table. There are some differences in like formatting control that you have with HTML, but actually, you know, you can do things in Markdown that mimic that sort of control. So it's not always lost there. And then in Markdown documents, you can just put an HTML table in there if you really need the formatting control. There are all sorts of different things you can do in Markdown. You can make line breaks. You can do different, you know, formatting things. It's just a matter of learning the syntax for it. So now let's compare how bulleted and numbered lists are built. So you have these bulleted lists and these numbered lists. So, you know, with bullets and with numbers, you want to sort things and present them that way. 2 of these are written in Markdown and the other 2 are written in HTML. So you can't necessarily tell which lists are made in which language, but I'm having trouble with this today. So this top one is made in Markdown, and you can see it's just like basically listing it in text, putting little stars here. This one is in HTML, and you can see that you have to do a more formal opening and closing of tags to generate this list. The same thing with this numbered list. This bottom one is Markdown, and this top one is HTML. And again, it's a similar situation where you have a list that's, you know, you have to have all these tags in here. In Markdown, you can just write it like this, and it comes up. And the way you get a Markdown document is basically if you go to GitHub and you create a document with the extension .md, that will give you, it'll automatically take any Markdown you have in that file and convert it to this formatting. So it's actually a pretty easy way to generate it. Or you can save, like you can have a document on your computer and just save it as .md, and you open it up in a Markdown editor and it'll show up. So, you know, you can add in the HTML and LaTeX elements, like I said. This is an example of a very simple document where I've added in, this is in Markdown, the text, aligning this to the center and putting this image in is in HTML, and then this is done in LaTeX, this equation. So it lines it up, it gives it the characters it needs, and then it allows you to put the numbering in. And so this is the code here where you have the Markdown tag here for a header. You have this HTML code, piece of code where it aligns the image, and then you have this LaTeX element down here, which is the LaTeX, you know, all the symbols that you need to put in. You know, so it's easy to integrate, basically, is the point. Now, Markdown is versatile and long-lived, but there are a number of things we have to consider here. So it's a lightweight markup language. The layout and style are very easy to learn and easy to work with, but it's not standardized, and there are many flavors that aren't cross-compatible. So if I write a document in R Markdown, I can't necessarily convert all of that to GitHub Markdown, and so it's a problem. There's a shallow learning curve compared to HTML and LaTeX, and this is why I'm presenting this to people today, so that you can learn this very versatile language for generating documents, and it allows you to think in terms of code, and it's a nice stepping stone from like no code to like something that you can really kind of control, and it's a nice it has a nice shallow learning curve. But then it also has limited control over specifying formatting and text and all that. Also, there's a issue about semantic specification. So in HTML, there are different ways you can deal with semantic specification in other languages as well, but you can't do that in Markdown. And then finally, there is this platform agnostic aspect to it. It has a basic flavor, but that basic flavor has stylistic limitations. So the examples I was showing you here with HTML and LaTeX elements, that you can do that in GitHub. I don't know if you can do that in the standard Markdown flavor, like the generic Markdown flavor. Depending on where you compile your Markdown document, it may or may not support these things. So I think final thing to take away from this is that you can use Markdown as part of a pipeline. So we use Markdown as a means to an end. So we're generating all these different artifacts and documents. We want to be able to create documentation, or we want to be able to review code more effectively, or we want to author collaborative documents where we want to be able to have people add their content in, maybe on GitHub, issue pull requests, and do things that aren't like where you have to where you have to pass the document around. You can track all the changes. So those are that's why maybe you want to use a Markdown document to do those kind of things. And you would push your Markdown document to GitHub and work from there. And we're not doing that right now, but we can do that. But then taking that GitHub document on Markdown, we can also convert it to different types of documents. So we can take that simple Markdown document once it's done and convert it to a documentation platform. So they're like Read the Docs is a documentation platform where it renders different documentation in a readable format, but the underlying part of that is written in Markdown. You can generate HTML documents, so you can just convert the code over, or you can convert it to other types of files, and that's where this Pandoc comes into play. And Pandoc is a library that allows you to convert your Markdown, especially to PDF, but other formats as well. And so using this as part of a pipeline, you can see that you can take a Markdown file, put it in, plug it into this Pandoc library, which is actually pretty archaic, but then you can output this into a number of different file formats. So people use text, which is also something that you might use Overleaf for, or HTML. Overleaf uses Pandoc, by the way, as an underlying library. You can generate PDFs, EPUBs, which are books that are written, in this format, and then you can convert it to a doc file if you wish. And here are some references. I can share these slides after. People are using Pandoc to produce research papers. They can write their book using Markdown and Pandoc, or they can create semantically rich documents with Pandoc Scholar. So when you use Pandoc, you can introduce semantic elements into it as well. But it's a very archaic, you have to use command line stuff, and it's not easy to kind of work out. And so Overleaf will take care of that for you, but Overleaf has some limitations. Another tool you can use is called Atom.io, and this is something you install on your desktop, and it's actually kind of an easy platform to use. Basically, I've done some tutorials on this. It basically allows you to convert a doc and integrate those documents with your GitHub repos. So if you're using GitHub, you can take a document, you write it in this untitled window here. I've written a short example of Markdown here, and I'm going to save it as a Markdown file. And then I'm going to be able to take that document and I'm going to be able to push it to my GitHub repo just using this interface. I can also do other kinds of maintenance with GitHub. The GitHub is responsible for developing Atom.io, but it's a nice text editor because it actually has plugins that allow you to use that Pandoc library to convert the documents in different ways. So Atom.io has a lot of nice features for that sort of thing, for converting documents, for working with them. And so, you have to install libraries, but it's actually quite easy. And it's all like this sort of, graphical user interface driven thing. So it's actually kind of easy to work with. And I've done some tutorials on this. You can check them out. And then if you want to learn more, you want to use Markdown for technical writing. There's a tutorial here. Someone's saying why you shouldn't use Markdown for documentation. So I always like to give these like pro and con examples. Why you should not use Markdown at all, or someone with that position. And then someone asking what's wrong with Markdown. So you can see there's a contention there amongst people as to whether it's a good approach or not. But I like it because it allows us to generate documents quickly and with not very much technical overhead. And I just wanted to present that. We have some things in the chat here. So Jesse said, would people be interested in a GitHub tutorial? Yeah, I think we should do one. We can do it in the session here, or we can do it separately. I think a GitHub tutorial is, like the basics of... There's a lot of documentation on, like GitHub's produced on how to do things like pull requests and things. And I throw that terminology around, maybe knowing that some of you don't know what that is. So I apologize, but there is a sort of a terminology lift there where you have to like learn terms and how they do them. But once you do, it's actually not that hard. And then, so yeah, we would like to do that, I think.
So GitHub, for those who don't know it, GitHub is extremely, I would honestly just say, not user-friendly. It's maybe it's a little bit better now, but GitHub is not. It's intimidating and awkward and weird and very idiosyncratic and not really that intuitive. However, it's a great thing to, even if you just go there, make an account, join our group, and learn how to post a simple Markdown document. Markdown is extremely common for documentation, and if you ever make anything with code in your life, which you're probably going to want to do at some point, whatever your career is, being able to just having people to help you kind of walk through, okay, you've created your first repo, and now you have a README in it, and knowing what that is, like that's a great. It may not seem appealing or whatever, but especially if you're not really into coding, having a sense that, oh, I understand what GitHub is and know how to make a Markdown file, a README file, and comment on it, and upload some files to my repo. That's a tremendously great thing to do, because if you take away that barrier of, oh, this is so weird, how do I do this? It will be much better for other things down the road. So we may talk more about that later. We'll see. But it's a good thing to know, and this is a great place to go through the awkwardness of what the hell is a fucking, I shouldn't say that. What's a pull request? Because I'm like, what? It was so confusing. I'm like, what is this thing? And why are you calling it that? So, anyway, keep it G-rated. The next comment that I had, my comments in the chat were unrelated to Bradley's talk. But is there any questions? Does anyone have any direct questions for what Bradley said before we say things that aren't related to it? Because I might pull in other directions after that. Guessing it doesn't look like it. Sorry, I couldn't tell if someone was muted or not there. Okay, so the comment that I remember something about MIT hacking stuff. and you can read the comment, but it's basically just saying, I don't think I finished my story there because I was a little confused by stuff, but basically hacking was a cool way to add things to the campus. And when I went to the campus the first time, I was like, oh, that's what you mean by hacking, and so it was a nice sort of see that. Another great use of Markdown is Obsidian.md, which is what I'm doing a lot of my frontier map stuff in. And I might, if you're okay with that, I don't know what else we wanted to do today. I know we're kind of like 20 minutes left or so. I might quickly.
We could do a short 5 minutes. We'll do.
Yeah, and this is actually hopefully going to be like a live use of it, because I'll cover really briefly the machine learning street talk thing I mentioned earlier. I took notes on it I'm starting to use Obsidian really as my major. I really like it, and I also done something this week to help Obsidian. I'll start sharing my screen so you can see a bit about it. Obsidian is a application, a program that's basically for note taking. You've probably seen this earlier, or I was previously. I think you had this page. And basically what it is you see on the left here, this is your name of your, I don't know, vault they call it. You make a vault, and in the vault you have all these are all individual like files, almost like little web pages or like documents. And the documents are formatted in Markdown. You can see this is currently showing, now that I'm clicking on it, it's showing the Markdown formatting of the hashtag. And if I change it and do 3 hashtags, 4 hashtags, it's not much. Now it's like H4, a much smaller header. And if I go back, it's a normal one. And when I click away from it, it takes away the latest version of Obsidian has a pretty seamless transition between coding view and like the output view, what it would look like. But Obsidian is kind of what I'm using as a means by which to. It's basically become my major notebook. Like I've used a bunch of apps from like Notion and OneNote and all sorts of things on like iPad for taking notes on different things and writing notes. But I'm really interested into Obsidian right now because of the way it's just so easy to put stuff here, and then when I put stuff here in Obsidian, I can link to other things. Like if you could, some people are very put off by this view, and you don't have to ever use this view if you don't want to use it. But I personally like this view because I can see all the connections that I've made in the paper. These are all internal, these are all links to other articles I've made within Obsidian. I'm gonna try to do like this. Can you still see my screen?
Yes.
Okay. These are all things that this is the title. So look over, if you see over here, it's currently sideways. This is a little bit of a different view, but this is the title of this note or this page, whatever you want to call these things. This individual document. And I've titled it ML Street Talk, date, Gary Marcus, and you can see, I have a link to a very simple page right now on Gary Marcus that I have 2 hashtags and some other stuff. And this page is linking to like my main people's page, which has a lot of people in it. And I can kind of just go back and forth through a lot of these. I can go back and forth between these different things. And I can't quite see how to actually return. I don't know. There used to be. Oh, here it is. Here it is. Okay, great. So I'll really quickly go through Markdown and Obsidian, and also go through this specific thing. I was literally, how this came about. I was literally just, this came on. This was someone recommended this to me, and I'm like, all right. I was kind of listening to work stuff, and I was like, hey, I'll put this thing on the background, and it was like really good, and I took notes on it. And basically, this is what it is. I'm not gonna play it. It's pretty boring. It's just 3 guys talking about nerd stuff. So not really anything, no exciting pictures or anything. But you can kind of see they break it down into these Gary's intro and these other topics here. Cool. But what I ended up doing is I took my own notes on it here and expand a little bit more. You know, this is an H1. This is an H2 with two things. Most of what you're going to be using in Markdown really is probably just the headers, and you can throw in some links if you want, and some images too. This Obsidian's great because you can really just literally drop links in, and it's very convenient. But for those, I'll shift focus slightly and actually just mention what Gary Marcus is about. He's basically on the side of we need to make hybrid neurosymbolic architectures to move AI forward. And he's on the cognitive science side of things. We need cognitive structures, and a lot of deep learning and machine learning hasn't really focused on that too much yet. And he's kind of a critic or a gadfly or someone who has been seen very antagonistically in the machine learning AI community, because he will constantly kind of deflate the hype around, oh yeah, AI, we're 10 years away from all these great superhuman-like things, and Gary's like, well, we don't even know how to make this certain cognitive structure yet, so how are we going to do that? That's a lot of his stuff about it. And he's kind of got this, they went over this kind of 4-step program about making these architectures having some innate structures in the cognitive frameworks, and then associating and relating them, building them out around these large-scale knowledge databases, making tools for abstract reasoning over these frameworks, and you talk a little bit more later, and then more sophisticated mechanisms for representation and induction and cognitive models. So it's kind of like we need to build these structures out. We need to have cognitive frameworks and knowledge databases. We have to be able to abstract reasoning across the frameworks and then really, really, really enhance that. That's kind of his super general model. And if you don't really know what that means, it's fine because it's very vague. But he's kind of trying to outline a very broad sense of what progress would look like. The conversation kind of started out with this tweet being discussed of, it may be that today's large neural networks are slightly conscious. And, you know, this is a researcher in the field. As a contentious tweet, you can see Jan LeCun saying, no way, basically. You know, neural networks are not consciousness in computers right now. And there's a big discussion about that. And the question was posed to, I think to Gary, are you a computationalist? And further elaborated by, you know, do you believe in substance dualism? Which I never really, I think I heard the term, but I don't know what it is. So when I heard this term, I typed it out, and I basically did, okay, and then I put 2 sets of brackets around it. And if I go here, I don't even think this page exists yet. Yeah, it actually didn't exist until just now when I clicked on it with like control. And why I'm mentioning that is because when you're taking notes in a rapid fire situation or a live discussion, it's great to be able to say, you know, I'm going to mimic it. I'm going to say, okay, substance dualism test node. And in reality, I just basically made this thing where like it doesn't really exist right now, but if I want to further elaborate on this later, I can go back and say, okay, what is this? Oh, I can fill out this specific thing with more detail now when I say, what is substance dualism? And it's a great way to, or I can like click on this and put double brackets around anything if I wanted to do one for mind. And then I could just create this little hub that's very seamlessly, I go to anything I say about mind here and say, oh, I want to put Gary Marcus in here and mention 4 steps that he talked about. And then I'll link and I'll say, oh, that was mentioned in Mammal Street Talk. So now I've really quickly linked a bunch of things on this topic of mind. And I know might not seem like I'm doing anything, but when you start creating these really highly complicated webs of notes and things like that, um, it I find it very useful to just have the links accessible. And also, like, I don't know this would be a good example, but like I just mentioned Abeba Birhane, who's I really like her work. And you can see all the different places that I've mentioned her and tagged this person's name in my other notes and these links here on the side. So this is showing me a situation where I've already tagged her in another note. And you can just browse through those things pretty quickly. So to keep it moving here, there were a lot of cool things. I'm going to delete this because it's really... what did I want to mention? Oh, just as an example, here. There was a really interesting question that was posed to Gary. It's like, what's the practical importance of being able to recover the different components to a highly involved, like, cognitive model, basically? And it led to Gary saying something like, sharing representations is good and important, and he said specifically, there's no way towards AGI, or basically advanced AI, artificial general intelligence, without being able to have shared representations. And I believe he basically meant internally, as in between, being able to create a representation structure and move it through different parts of the mind. And this is actually really tied to what we're talking about with hacking. Like, you create this structure of a language or a word or a book or something, and being able to sort of use and manipulate that around there. And just to kind of show off Obsidian quickly before we move on to something else, here's the tweet. And actually, it's kind of cool because I think Gary Marcus, like, retweeted it himself, so that's cool. But let's say I want to take a screenshot. Oh yeah, look how cool I am that Gary Marcus answered my question. Really quickly, I just drag and drop it here, and there it is in your notes. And it's actually saved as its own file too. You can go here to the file of this thing too. It's saved here in the screenshot area. But for a really rapid fire way to take notes on something that's happening live, it's a great way to do it. And you can go back later and make much more refined things. Like, I'm going to go back and look at GTP Jade or Yasmin Razegi. These are two people that I really wanted to follow up on because I couldn't figure out I don't know much about them entirely. And a bunch of other things here that we can get into at some other point. But I think it's a great way for taking really quick rapid fire notes and really easily format them and drag in some links and take a picture and build out things with it. And I'm not I haven't finished my public version yet, but I'm continuing to work on my template of basically giving someone a version of Obsidian that's mapped out in terms of finding and sort of hints and ideas about how to find these key parts of a frontier map, like debates people, academic papers, and some of the motivation about why you're doing it. So this is forthcoming, but that's my preview for now. So
Great.
I'll leave it at that. Any comments before we move on to anything else?
I saw that network of concepts, and I thought, like, I forgot to talk about connected papers, and I know that's something you are like.
Yeah.
And so when I talked about, like, searching the literature and finding things that have been cited in papers, that connected papers allows you to build a network of, like, if you have a paper, it will build a network of the citations, and then you can follow. It's like just a graphical representation. You can follow that back, link by link, to different papers. And those visualization tools are nice because they give you You don't have to wade through a bunch of text. You can just see the relationship. But yeah, I like the way that Obsidian also deals with those kind of relationships, how they're connected together. Um,
Yeah, and it's sort of like it's really tough because what I'm showing you, like what I just showed you was like a raw note file, and it probably won't make the most sense to you because it's not formatted for you as an external viewer. You're not in my mind. You don't know the context. But I think Obsidian's probably the best thing I've seen in terms of being able to have it markets itself as like your second brain, as a place you can just store stuff and do it. And I think there's a next step is kind of combining basically a lot of Bradley's Markdown talk is like how do you what's a very simple way to format some of your ideas and understanding headings and some links and stuff that other people can access. And Obsidian is kind of focused on your own personal development of your cognitive models and your associations and your notes. But it's important to, and there are ways to build it up and build it out and continue to go in that direction. So we may say more about that, but I'm being very brief now because I think we might have other things to discuss. So thank you for the time on this stuff.
Yeah, no problem. So yeah, I mean, if you have other comments, we can talk about them in the Slack. Questions about that, and we'll probably do a GitHub tutorial at some point too. So I want to talk about a couple things. I'm going to maybe talk about a paper, but first I want to talk about the A-Life conference. So the deadline for that is Monday, and I've been working on two things with Jesse and with Ankit. So let's see if I can share my screen. So the A-Life conference. What was that?
Are those both submitted now?
Yeah, they're both submitted. So these are this is the layers, folds, and semi-neuronal information processing paper. This is the one that this is something that Jesse and I worked on, the MetaBrain models, and so this is a takeoff on the MetaBrain work. So this is like some of the stuff that we have a main MetaBrain paper that is in press for like an ebook, but this is a different version of it. This is where we go from like that idea of brains with, artificial brains with layers of representation to looking at other biological structures that have this same layering and folding, these layering properties we're adding and folding as a topological property. But we're asking the question, can we use this sort of metabrains approach to look at embodied phenotypes? So, we don't think about, like, when we think about embodied robotics, we think about the brain, and we talk about the body, and we stick a body in there, but we don't think about the body as like an information processing thing in and of itself. And so that's kind of the motivation for this, is to say, like the gut, or in fact, the gut is referred to in the neuroscience literature sometimes as a mini brain, or the leg, or the arm. I mean, our arms and legs process information. We have nerve endings in our arms and our legs. We have neurons. The peripheral nervous system has a lot of sort of complex control. There are loops in the spinal cord, for example, that process information locally. So there's a lot of stuff that goes on outside the brain with respect to information processing. But there are also different, within the tissues, there's information processing in terms of regulating the current state and other physiological state and other things that we can get at with this issue. And so this is the final version of this. So I showed this a couple weeks ago, and it's a lot better. You'll notice that when last time I showed you, it was very disorganized in parts. Now we have an abstract, we have an introduction, we have some headings that are a little bit more descriptive, fleshing out some of these issues here: germ layering, topographical anisotropy, which means that there are things that are organized in layers instead of at random, or in different with different sort of properties. There's this laminar organization. So there's layering, and then there's folding. The folding is a different thing than layering, of course, because layering is where you have multiple things, sort of like, when you layer blankets on a bed, you have different layers, and the more layers you have, each layer is doing something different. In the case of folding, it's where you're folding the blankets together, and you're doing that for a different reason. There's a different topology there, and there are different examples there. Then this is the diagram, one of the diagrams in the paper, where we have the metabrain, which is this basic layering structure here, and there's this morphogenesis that allows for folding. So all of this layering and this folding together have functional consequences. The representational layers are here. So each of these layers have a representation of something. So, in this case, in the bottom layer, I think there's another figure in here where I show this. In the bottom layer, there's this lowest representational layer of muscle. So you have these little ganglia of muscle that are connected, and they're activated in different ways. So this layer consists of a lot of these different ganglia. They're independently being activated, then they're maybe being activated synchronously, and then that's doing something. And then that feeds up into the next layer, which is this embedding, which is a way to process the information coming up from here. And then C is this allostatic regulation, where you have, you're generating a state from this embedding. And so everything in this muscle, if all of them are being activated simultaneously and synchronously, it's feeding into this embedding, which then generates a state. So if they're all, everything is synchronous, then that's a state that gets sent up to this system, which is where you monitor the current state, you monitor the next state, and then there's this loop, which allows you to control things in time, regulate things in time. So there are these different layers of representation. So that brings up another question, which is, if we talk about representation in the brain, we're talking about some intentional cognitive process, theoretically. It could be, but we do have connectionist models which don't have a lot of intentionality. But, when we deal with physiology, we're dealing with something different. We're dealing with processes that are autonomous, but they're not necessarily intelligent. But they are adaptive, and so this is where we're going with this. We have these different computational structures, and they produce different outputs, and then those things are joined together, so they're doing different things, but they're connected. Those things are put together in sort of a developmental model where you get this layer first that emerges, the muscle layer, and then that gets built upon by this embedding, and then lastly this regulatory layer comes in. You could have a metabrain with 2 layers, but it wouldn't have the same sort of regulatory ability. So that we can look at this. This is a hypothetical tree, but it shows how you can have an agent that has these different layers, maybe just 1 layer, maybe just 2 layers. And I didn't show the effects of folding on this, but folding can also have effects on this as well. So when the representation is folded over topologically, there are different consequences. For example, this embedding changes its shape, and it can be connected to this regulatory layer in different ways, or the muscle layer in different ways. And so that's that's the paper, and then I actually bring in our Bratenberg vehicles here as an example of some of these things, and then it didn't have a lot of room. There's probably room for a fuller paper where we can lay out some of these ideas in more detail. But so then the other one I'm working on with Ankit is this universal theory of switching. So this is where we had a meeting on this, where we talk about this switching mechanism, which is cybernetic in origin. It generates a regulated state, and then we use 2 examples, one from a gene expression in cells, and another one in, is this the right one? I guess it is. It's only 2 pages, I think, but, and then the other one is task switching and generalization in computational agents and human cognition. So this is where you're dealing with, an agent or a human who's doing one task, and then they switch to another task, and can they transfer that knowledge over? And I'm actually using this example from motor learning, where it's a very famous set of examples where they've shown that if you switch the spatial reference frame of something, like if I teach you how to reach for a cup in a spatial reference frame that has a table, but then I also teach, then I want you to reach for a cup that's up on a set of stairs. So, that's not the same thing. This is a flat surface, this table. The set of stairs is where you have to figure out how to reach up the stairs and grab the cup and bring it down. So, there's some transfer of learning there, but it's harder to sort of generalize that. In motor learning, they also do this thing with force fields. One really nice experiment that was done, it's kind of a weird experiment where they put someone on one of these, what do they call them? The merry-go-rounds, or they put them in a merry-go-round, and they made them ride it in a circle. So you're moving around, and you're throwing clay balls at a target. So you train someone by throwing clay balls at a target, just standing there and throwing them at a target maybe 90 feet away. And you get pretty accurate. But then you put someone on a merry-go-round, and you have them go around the merry-go-round and throw the clay balls at the target. And of course, there's this aspect of motion, it's harder to do. And then you take them off the merry-go-round and you say, throw these balls at the target. And now so you've mastered both of these skills, throwing them from a merry-go-round and throwing them from a static position. But then when you go to the example where you've just been on the merry-go-round, there's this after effect where it actually interferes with your performance, but it does so in a systematic error. There's some systematic error that's introduced there. So, this is the kind of thing, that, again, we can build that bridge between what we do in human expertise and expertise learning, and then what we can train computational agents or machines to do. So this kind of brought this up in the context of switching. We did both of these examples. This is a 2-page extended abstract, so hopefully that makes it through. But there's another chance for a bigger paper later. And we're actually talking about this with a couple of you, where we want to do a larger paper. We want to lay out some of those examples in more detail, and we want to maybe bring new examples to bear. But we can talk about that later. Now I'm going to go to the paper. I'm going to pick a paper out of Fermat's library, and I'm going to go over it. Let's see. Maybe this is a nice paper. Towards disciplinary disintegration in biology. And like I said, I'm going to go over these just kind of quickly. But I wanted to
ask you a really question.
Yeah, go ahead.
Have you ever heard of the paper, What the Frog's Eyes Tell the Frog's Brain?
Oh, yeah.
A long time ago.
Yeah.
I've never read that paper, and someone just asked me about it. So.
Is this something that, let's see, actually this is the paper. Did we go over this before or not? In the meetings.
Oh, cool, there it is.
Yeah.
I don't think so.
Well, why don't we do this? Why don't we do this one? And by the way, this paper here, the layman paper, is the one I was kind of referring to with respect to the innovation and evolution. So we can talk about that next week, maybe. This is a nice paper on the surprising creativity of digital evolution. So people have been doing work with creativity and innovation and digital evolution, which is a simulation of evolution. But we'll talk about this one. What the frog's eye tells the frog's brain.
Actually, to give full credit and also mention again that we have many people in our lab who are not at these meetings, the person who showed me this paper is Jenny from Plot Twisters, who she's looking a lot at cybernetics right now, and she asked me, maybe I can also mention her question to you and like have you comment on it through the paper or after the paper. But she basically she asked the classic question of like something about the different layers of cybernetics or something like that. Like how is it? No worries, Shaima. Take care. She asked. Where did it go? Here it is. Okay. How do you compare the waves of cybernetic theory
Monterana versus Wiener versus McCulloch, and so on. So maybe something to keep in mind for like all this stuff.
Yeah, that would be good. Yeah, thanks for that. I didn't hear that conversation, so thanks for bringing it up. But yeah, so that's good.
Oh yeah, it wasn't.
Oh, well, yeah.
It
So
wasn't in this.
this is Maturana, who is one of the authors of the autopoiesis idea. So this is the Maturana and Varela idea for complex systems being autopoietic states, and you can look that up. And then there's Warren McCullough, who was one of the originators of the concept of the sort of the artificial neuron that we use in connectionist systems, and it was a more physiological model than, and of course Walter Pitts, McCullough and Pitts, of course, the people who developed the artificial neuron, the neurophysiological aspects of it. So like the idea that you have inputs and that there are thresholds and things like that into a neuron. So this is they talk about the behavior of a frog. So a frog hunts on land by vision. He escapes enemies. Gender the frog here. He escapes enemies mainly by seeing them. His eyes do not move as do ours, follow prey, attending suspicious events or searching for things of interest. Body changes position with respect to gravity. The whole visual world is rotated about him. So this is what I was talking about like visual spatial reference frames. If you have the if the frog is looking at a target and you turn the frog upside down, they have a different spatial reference frame to the environment. So it's a different, they have to relearn things in that skill set. I don't know if this is the paper. I think what they're doing is they're looking at, okay, yeah. So this is something he has only a single visual system, retina to colliculus. So this is the neuroanatomy from the eyeball to, the central nervous system. Not a double one such as ours, where the retina sends fibers not only to colliculus, but to the lateral geniculate body, which relays the cerebral cortex. So the frog has a simpler pathway. So we chose to work on the frog because of the uniformity of the retina, I think this might be the experiment, or there was an experiment by Sperry where they took a frog and they took the eye of a frog and they cut it and they rotated it 180 degrees. And so just the eye. And so when you do that, the frog sees the world, but it sees it at a different angle. So what does that mean? Well, that means that you see very similar results to what happens when you do. I told you about that experiment that people have done on on merry-go-rounds, where they put someone on a merry-go-round and they muck up their spatial reference frame, and then they have the systematic error of throwing clay balls at a target. In the frog, if you do this surgery and you move the eyeball 180 degrees, when they shoot their tongue out at some insect that they're going to eat, they can usually hit the insect. But when you do after the surgery, they shoot their tongue off to the side at a systematic error. So again, the spatial reference frame comes into play. So this is what they're getting at in this paper. They talk about the visual apparatus. So it's the eyeball. There's a simple pathway to the brain. So if you cut the eyeball and you turn it and you let the frog do its thing, there's the systematic error. It's basically the orientation of the eyeball relative to the spatial world. And so they talk about this experiment by Hartline, where they first use the term receptive field of the retina. So the retina has these receptive fields, takes in information from the environment, and it maps it to sort of a spatial model. So each, the retina has a number of ganglion cells that take in light from different perspectives. And then, if there's like this thing in the environment, then it's recording that, what it's seeing in those receptive fields. Some of them can see it better than others. Some of them are activated depending on what's in the environment. If there's something crossing your line of sight, different receptive fields are activated, and then you get this map of receptive field activity. And then this is how you can actually behave in space. the receptive fields can be on, off, or off. So if a small spot of light suddenly appears in the receptive field, you get an on cell. The discharge of the cell soon begins, increase in rate to some limit determined by the intensity of the area of the spot, and then it declines. So it's activating the neurons associated with this receptive field in that, there's a ganglion cell, it's activated, it fires on, and then it discharges, and then, if there's that stimulus stays in place, that cell continues to fire, and, because the cells are distributed around the retina, you get this spatial map. So Barlow extended Hartline's observations. Barlow is another neuroscientist, and so they observed that the off cells have an adding receptive field. The response occurs always to off at both center and periphery of that field, and that effect, the removing light from the periphery, adds to the effect of a reduction of light at the center, with the weight decreasing with distance. So if you change the stimuli in the environment, it changes the receptive field, respectively. And so but you get this decay. So you get, if there's something in a certain part of the environment, say dead center to you, you'll see it, and those, it'll be in the center of the receptive field, and then there's a decay across the retina in terms of like your peripheral vision will be not active, but your core vision will be active. And if there's something in the periphery, that's the opposite. Your receptive fields in the periphery will be on, and the central fields will be off. And there's this thing, and of course there's this link to attentional control, because this is something that happens in visual attention, where you pay attention to what's sort of salient in your environment, and you shut out other things. This is a different mechanism, of course, but it's related because you want to pay attention to what's most salient. If there's a truck coming at you, or if there's a prey in the environment you want to grab, you need to know where those things are in space, and maybe you don't care about anything else. Sometimes that's not great, because sometimes there are threats in the periphery, or where you're not looking, where you're not attending, and so that's not great. But they lay this out. It's very physiological, and so they kind of go through this. It's very they kind of lay out this about the receptive field. So basically the eye is telling the brain what to do, and it just kind of works through the neurophysiology of the receptive fields. They work through contrast detectors and things like that. So there's a lot of physiological trace in here with spikes. I don't know if that's necessarily as informative as the idea that, basically you have these receptive fields. They decay with distance, with space. They're activated based on what's in the environment. And that's all telling the brain kind of what's in front of you, what to act on, and this sort of thing. So you can do this in the frog. It's easy as a experimental model, but of course this relates to what's going on in humans, because the eyes, at least the receptive field biology, is very similar. And so, we can make, and even, in computational agents, it should work the same way. And people have modeled this using a neurophysiologically inspired computation, and it works very similarly. So, and so they have a bunch of different details in here. So let's go to the discussion here. Let's compress all these findings into the following description. Consider that we have 4 fibers, one from each group, which are concentric in their receptive fields. Suppose that an object is moved about this concentric array. The contrast detector tells in the smallest area of all, which is the center, of the presence of a sharp boundary, moving or still, with much or little contrast. So it's detecting boundaries, it's detecting contrast between the object and the background, and it's doing all these things that are really kind of detecting contrast. Then there's a convexity detector, which informs us of a somewhat larger area, whether or not the object has a curved boundary. So if something is curved, something is sharp, whatever, at the boundary. The movement detector tells us whether or not there's a moving boundary, within yet a larger area within the field. So we want to track that object across space. We want to have this account of movement, And so we have this movement detector, which is activated when things are displaced. And then the dimming detector tells us how much dimming occurs in the largest area, weighted by distance from the center and how fast it happens. So this is another spatial, actually a spatiotemporal thing, where you're looking at like dimming. If dimming occurs and there's a difference in the receptive fields across space and thus across time. Now these are 4 examples. These are in the Frog, but you can imagine that you could build a computational agent with different types of detectors that are multimodal like this, and you could get different information and then stitch it together later as a way to, kind of evaluate different stimuli. So that's how, the eye tells the brain what to do and how to do it. Thank you, Samantha, for attending. Thank you, Shaima, for attending. And Sadena. And that's all I have on that paper. So are there any questions?
No questions. But I appreciate going through that. I'm probably going to look at it again and think about it in terms of the context of Jenny's question. Also, that question wasn't in Slack, so don't feel bad if you didn't see it. It was something that came up kind of in a side discussion. But, yeah. Cybernetics and stuff like that is always interesting to me. But, that's all.
All right. Okay, so any other things before we go we wanted to mention?
Or, if anyone's still here, any particular thing you'd like us to focus on next week, or that's on your mind? Because I know we kind of had a certain flavor to some of our meetings so far through the topics, but we're open to tailoring it to specific interests too. So just putting that out there too. You can say it in the Slack also. But otherwise, good to see everyone again.
Yeah. And next week maybe we'll cover more on the GSOC project, and then maybe some other things on. So we'll talk more about different things next week. Always shifting focus a little bit.
Mm-hmm.
Great. Have a good day or a good week. Thank you.